It's Math with Mr. Antoine. I'm Mr. Antoine. Thanks for coming back for part 2. We're finding the solution to the system of equations using the elimination method. Just to recall what we did in part 1, and I hope that video was helpful. We're talking about these two equations representing two lines. Okay, this is one line and you have a second line, and somewhere along the way these two lines are going to intersect at a point. That point is what we call the solution. All right, the solution is a coordinate. So what we're going to do is now, instead of just doing it with a graph, we're now going to do it algebraically, take the two equations and be able to find the coordinate where the two lines intersect. All right, so let's see. Now in the first one, it was kind of easy to do because when you add the equations, one was a positive, one of the variables had a coefficient which was positive and the other one was negative. But in this one, we don't see that happening. So we have to do a little bit more work. Here's what we're going to do. I'm looking at this 3x in the one equation and 3x in the second equation. And being that they both have a 3x, but one of them doesn't have a negative, I'm going to negate the whole equation. And I'm going to take the top one. I'll explain it in a minute why. But I'm going to negate the top equation. So I'm going to make this whole equation negative. What I'm going to do is, since I'm negating it, every sign or every operation that I have inside here, I'm going to change it and put its opposite. So it's kind of like distributing this negative, in this case, to the three parts inside of it. Okay, so what's going to happen, I'm going to get a new equation. That new equation is going to be negative 3x. It was positive 2y or plus 2y, which now becomes my minus 2y, and equal to, that now was negative 13, that's now positive 13. Okay, and now I take the equation that was here, don't do anything to it, leave it the way it is. It's not going to be, let me put it in a different color just to show that we're just keeping it. All right, it's going to be 3x plus 4y is equal to 1. Okay, and what I'm going to do is add these two equations. All right, so let's add them up. Now again, I can eliminate because now I have a negative 3 and a positive 3. That's going to eliminate, leaving me with 0. So now what I have here is I have a negative 2y and a positive 4y. Add those up and I'm going to get 2y. And now this is the reason why I kept this. I wanted to negate the first equation, is because now when I negated it, look what I'm dealing now. I just have a positive 13 and a positive 1 that we know that's going to be 14. So now what I have is 2y is equal to 14. Divide by 2, divide by 2, and y is not equal to 7. Okay, now remember before in the part 1, what we did is that I put the coordinate set up. I had my x and my y. Okay, so now I know that my y is 7, so I'm going to put 7 over here. I got that first part of my coordinates, all right, the y value. So now we need to get the x. Again, you can choose any of the equations that's up there. Matter of fact, you can choose this one, this one. You can use the new one that we made. But you know what? I want to use this one here. Well, a matter of fact, let's use this one down here. Why? All positive. Love positive. So here's what we're going to do. Let's use 3x plus 4y is equal to 1. Let me say it again. You can use any of the equations, but I'm using this one because it's all positive here. So now I'm going to substitute the value for y over here. Okay, so I got 3x plus 4 times 7 is equal to 1. Okay, we do the math now. I got 4 times 7. That will give me 28. And so we got 3x plus 28 is equal to 1. Now it's just a two-step equation. I'm going to minus 28 on this side. What I do on one side, do to the other side. And what I have here is 3x equal to negative 27. There's going to be a negative, but that's not a problem. At this point, we got divided by 3, divide by 3, and I have x is now going to be equal to negative 9. So my x value is negative 9. So we go back up to my coordinate, and I'm going to put for the x, negative 9. And there you have it, people. The solution, meaning the point where the two lines are going to intersect, is going to intersect at negative 9, 7. Hope that was helpful. Check out my third video, which is going to be a part 3. Again, it's a 4-part installment of finding the solution to a system of equations using the elimination process. And we'll talk a little bit more in terms of how to eliminate when we have another situation coming up. Stay tuned for that video. Love and peace.